2 through 5 is an interesting collection of problems because when we talk about the degree, it's easier to see it when we see the equation, but we don't see the equation here, but we see the potential. We see the graph changing directions, and in some cases it hits the x-axis, some cases it doesn't. This one's pretty straightforward because you see it go up, it crosses the x-axis, it changes direction, crosses the x-axis again, and when it changes direction again, it crosses the x-axis one more time. Okay, the 3 changes of directions means it changes direction once and then again, but basically you're going one direction, you're crossing over another direction, and then you're crossing back over. You're hitting the x-axis 3 times, so the number of real roots is 3, but the degree is also 3. You can think of the degree as potential x-intercepts if you're looking at the graph, and that's probably the best way I can explain it. Someone else might be able to explain it better, and I'll look for that. But if the degree is 3 and it crosses the x-axis 3 times, then there are no complex roots because these 2 things here, the sum of those will add up to that. Now that seems kind of weird, at least at this point. Well, let's look at this. Does this look like your typical parabola? Well, no, it doesn't. It looks like a parabola that someone dropped a bowling ball on. Okay, and boink, and it dented. Okay, well, it's not a parabola anymore if that happens. Okay. So the degree can't be 2. It can't just be parabola. If you cover it with your thumb, hey, that could be a parabola. That could be a degree of 2. But we see more information. It's going up. It changes direction. It changes direction again and changes direction a 3rd time. Changing directions 3 times means that it will actually be heading that up and then down and then up and then down. In fact, if you can say up and down, that's a 4th degree polynomial. Now the number of real roots are 2. It crosses the x-axis twice. And if we know that the sum of these 2 things should equal that, how many complex roots do you think there are? Well, that's right. There's 2. Let's do one more, and then I will talk to my guest. The degree potential, we're going up, down. That's 2. Then up, then down, and then up again. Okay, you can see, but I counted 5 there. The degree then is 5, and I'll show you another thing that will kind of help you there. The number of real roots, 1, 2, 3. 3 roots, real roots. Complex roots then, by default, these 2 things add up to that, is 2. Okay, we'll do one more. But one thing I want to point out, remember the end behavior. They're going opposite directions, so that means it has to be odd. Well, you can kind of do a quick check to see that that is an odd number. So therefore, it looks like we've covered everything. No real roots. Goose egg. The degree of this is not just a parabola. Down, up, I said 4 words. That's a 4th degree polynomial. The number of complex roots is 4. Sorry, I was